Saxon Algebra 2. Yes, indeed. Saxon Algebra 2. Lesson 82, Complex Fractions. Before we dive into the juicy world of complex fractions, we're going to review the three main rules of algebra. I'm even going to call them the three basic rules. Oh, the three basic. Oh, yikes. Rules of algebra. I don't know what happens to me when I'm teaching math. The words just go crazy in my brain. Okay, the first two apply to equations. You can always tell when you have an equation because it's got a cute little equal sign in it. Okay? What happens with equations is that, first rule, you can add or subtract any quantity to both sides without messing anything up. Obviously, it's the same quantity. You can't add 8 to one side and 3 to the other, right? So I'm just going to write any equal quantity, right? As long as they're equal. The second rule, and this is swimming fish. We've been doing this forever. These are not new rules. These are not hard rules. The other rule is that we can also multiply or divide any, and I'm going to put the word equal in again, but this time we have to say non-zero. Equal quantity to both sides. And the reason for that is that we can't divide by 0, because that would be frightening, right? Okay, so these are the two rules that apply to equations. But what if we don't have an equation? What if we only have an expression? And again, that's when there's no equal sign. We can't do this because there aren't two sides, right? When we talk about both sides, we mean either side of the equal sign. But what if there's no equal sign? Then we can only multiply. We can multiply or divide any equal quantity to the top and bottom, right? So with equations, we can go side to side to keep the balance, but with expressions, we can only go top to bottom to keep the balance. And notice that we can't add or subtract to the top and the bottom to change them. We can only use multiplication and division technically, but that's mostly multiplying by reciprocals. Let's not get into the fine details of that, but we can't add or subtract when we're dealing with a non-equation, when we're dealing with an expression. With complex fractions, they count as expressions, and so we have to use this rule as our one and only rule for simplifying. And that's what we've been doing all along. This isn't a newsflash. We're just putting a little bit of theory into this so that you can get a feel. All right. All right, these are getting quite complicated, aren't they? In the immortal words of Evie Jones, who I always think of when I'm doing these problems, we will smush and flip, right? We can only use multiplication. We won't really even think of it as division. We'll just think of it as multiplication. We will smush them, and then we will use reciprocals to flip them. That's our basic strategy. We go down to the deepest, darkest basement, and we start here. We need to smush these and make a single fraction before we can multiply by the reciprocal. So how are we going to add these? Matching denominators, right? It's the easiest rule in the world. This one's 1, so let's just put it over 1. This one's x. That means we're going to have to multiply this one by x over x, right? Now they'll match. And this will become x plus 1, right? X plus 1 over their new matching denominator, right? When you add fractions, you add the numerators, and the denominator just goes along for the ride. Okay, cool. We have smushed. Now we're ready to flip. We have to multiply this by its reciprocal, which is easy. But now we have to multiply it by the numerator too. Notice I'm ignoring this part of the problem right now. I've got enough trouble on my hands without dealing with all of that. So I'm just going to deal with this little part of the fraction right here. Okay, that's the way you handle these, just a little at a time. Now, my numerator is a. I'm going to put a over 1 because I don't want to hurt myself. If I'm multiplying the bottom by this, then I have to multiply the top by that. And I think it's super helpful to draw a box around this to make sure you did it top and bottom. Okay, this has all gone away. Now, I'm going to copy the other part of the problem. This is the same, the 1 plus. Now, this is what's going to go here. It's going to be ax over x plus 1. Whoa, how do you feel about that? That's pretty cool, right? We've simplified that all the way down. Now we have to do the same thing here. We have to smush this, then we can flip it, and then we'll multiply by the new denominator. All right, so this is 1 over 1. We can do that if that's helpful. We need matching denominators. That means, again, we can't like add x to it. We have the 1, but we can't do that. All we can do is multiply. So we'll multiply it by x plus 1 over x plus 1. That will give us matching denominators, and now we can write this as x plus 1 plus ax. Now I have parentheses here, but I can take them off because there's no minus signs anywhere in sight. So it'll be x plus 1 plus ax all over x plus 1. All right, that's the smush. Now we do the flip. X plus 1. This is always easy because you just copy that upside down. X plus 1 plus ax. Now, this has to be exactly the same up here. Right? This is the same top and bottom. I do that just to make sure. This cancels. And now this I'm going to bring over. It's a over 1. Right? And so, for my final answer, here's my denominator. I'm going to write it as a times the quantity x plus 1 over all of that, because I'm just multiplying it by 1. X plus 1 plus ax. Boom, shakalaka. Yay! We could distribute this, but when I check the answer, I see that John did not distribute it, and so we'll leave it in the same form that he does. Remember that distributing is neither right nor wrong. It doesn't really matter. Remember that we can't cancel these a's because this a is being multiplied. That's cool. But this a is being added. So we can't cancel anything there. That is our final answer. Oh, okay. And we only have one more of these problems, and then we're done. Aren't you sad when it's a fast lesson? Don't you wish it just went on and on and on? Just wait till next year. It will. That's a plug, isn't it? You're all just like, oh my gosh, I really can't wait till next year. All right. These problems, oftentimes, especially for students when they're just getting the hang of them, when you see how complicated it is, it kind of makes you want to cry, right? You think, no, it's too hard. I'm going to get lost and confused, and I'll need breadcrumbs in the woods when the witch tries to throw me in the oven. It's frightening, right? It is as frightening as being lost in the woods, and you feel like you're in the woods. But if you just go down to the cellar, which is the scariest part of the witch's house, but still, just do it. Oh my gosh, you guys, have I ever told you about my grandma's basement? It scared me endlessly. It was such a beastly basement. We had a basement in our house, but it seemed very friendly and easygoing to me. But my grandma's, ooh, she had a monstrous furnace, and there were a lot of spiders. Oh my gosh, no. Okay, but anyway, we have to face it. We have to go down here to the basement, smush and flip. That's the moral of our story. I'm sure I've told you that, but that's Evie Jones, who I think is still in Texas. I'm not sure. She was in Texas before COVID, and then, you know, life changed. Okay, we need to make these match. The denominators have to both be y's. We'll multiply this one by y over y, and now I can see this will become x, y plus 1 over y. Beautiful. It's smushed. Now we have to multiply it by its flippy. Reciprocal, flippy, potato, potato, right? Beautiful. That's going to cancel, but we better do the top as well. Y over xy plus 1. This is times c over 1, right? I'm just bringing that across. That was that, okay? We're multiplying that. Okay, this is gone. And again, this is all just this little corner of the universe. I'm going to rewrite this b over a plus, and then whatever this simplifies to, that will go here. Cy over xy plus 1. All right, it's kind of a lot, but we've got it. Okay. Now we have to do the same thing again. We have to make this denominator match, squish it, and then flip it and multiply it up by that b. Are you ready? Now this one's a little bit messier because our denominator is a binomial. So we'll have to multiply this. I'll do it over here. xy plus 1 over xy plus 1. Now these match, and I can write a times the quantity, oh, I forgot the 1. A times the quantity xy plus 1. I put it on the left side. Here I'm writing it the way I prefer to see it, on the right side. Plus cy all over our friendly matching denominator, xy plus 1. Okay? That's my new denominator. Now I have to multiply it by its reciprocal. I ran out of room, didn't I? Well, I'm going to have to multiply it by, I'll write it down here. I'm going to have to multiply it by x plus 1 xy. Oops, that's how mistakes happen. A times the quantity xy plus 1. That's the reciprocal, right? So I have to multiply that up here. Okay, these two are the ones that need to match, right? I didn't write them. I didn't have enough room to write them above and below, but I'm clarifying to myself that that's good. This all evaporates. And now all I have to do is multiply b times that numerator, right? Because this is, I can rewrite this as b over 1, if that helps me. And I'm going to put this in parentheses, and then the 1 is just nothing, so my denominator will stay the same. So it's going to be b times the quantity, xy plus 1, right? And then this is all the same. A times the quantity, xy plus 1, plus cy. Don't you wish we could cancel that? But we cannot, because we are adding. This factor is being added to cy. And so we cannot cancel when we are adding. We can only cancel top and bottom when we are multiplying the chunks that we want to factor. If we cancel. If it was just like this, yeah, we could cancel those out. But this is the deal breaker. So this is our final answer. And I look to see, did John distribute or did he leave it like us? So I look at the book and I see, oh, he distributed in the bottom. He left the top that way, but he distributed in the bottom. Let's distribute in the bottom and see if we get the same answer as him. This is not cheating. This is not getting the problem wrong. B times the quantity, xy plus 1. Okay, now we'll distribute. It'll be axy plus a plus cy. This should match to what John has. Ready? Let's see. B times the quantity xy plus 1. Yeah, we knew that. Axy plus a plus cy. Yay! happiness reigns in the world of John Saxon. Well, no, actually in the world of us. All right, that is lesson 82. We continue our work with complex fractions. Please enjoy these. If you can get them right, please feel smart. They are difficult problems. There's a lot to remember. And remember also that we are putting that third rule of algebra to work in these. We can multiply any number, top and bottom, to change them. Of course, we can add within them, but we're not adding new numbers to them. Let me clarify that, right? If we get the denominators to match, we can combine them, but we can't add new numbers. We can only multiply. Yay, 82 is over. Goodbye.